Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question related to our topic 9, oxidation and reduction, simply called the redox reaction, right? In question number 30 in 2018 Time Zone 1 May paper, asking something related to a really important phenomenon or process, electroplating. This time especially plating a piece of copper on an object, right? So remember, asking for combination that would be possible to plate an object with copper. So given you X, Y, and Z, so you are going to choose what can be the materials that used for X, Y, and Z. So mind you, remember, here actually talks about the conditions for a successful electroplating. So remember, basically, we have 3 conditions that must be met exactly asked by these questions. So remind you. The first point is that our object to be plated, in this case plated with copper or just any other metals in the future, object must be in the cathode. Why? Because cathode undergoes reduction. Reduction means our metal ions will then be undergoing reduction and becomes back the metal and stick on the object. So that's why the object must be at the cathode in order to receive the metals, right? And so secondly, the same logic, right? If you have metal stick on the cathode, it is only because the electrolyte is containing the metal ion, right? So that's why remember the second condition that must be met is that we must have metal ions circulating in the electrolyte. Otherwise, no metal ions are available to do reduction and stick on the object, right? Makes sense? So that's why second point, metal ions must be the ingredient inside the electrolyte. No matter aqueous solution or molten state, must be having the metal ion, right? To be one of the plus charge state of the ion, right? To be available in the electrolyte. And finally, that is an additional point that better you meet it. But the first 2 points, I would say, these 2 points must be meeting. Otherwise, electroplating won't be successful. The third point is just for convenience, is that we better put the metal that we are choosing in the anode. Why? Because we want to make good use of an effect called the electrode effect, that demonstrating that when the anode is no longer using inert electrode, in this case like copper, if we use copper to replace the anode with the traditional inert electrode, copper can actually preferentially discharge and undergoes oxidation. So what's the point? The point is actually when copper at the anode oxidize, they will replenish the loss of the metal ion in the electrolyte continuously. So that's why we no need to change the solution of electrolyte constantly, right? Because the metal will be self-oxidized and so replacing the metal ions. And so the metal ions can continuously migrate to the object and do reduction. So this is a normal common practice, especially in the copper plating industry. So if you know what I mean, then you properly get to know the choice, right? And just the final reminder for you is that in the case of electroplating, or simply known as the electrolytic cell, the positive and the negative electrode goes in this way. Anode will be the positive charged electrode, while cathode is the negative charged electrodes, right? So that's why in this case, we will be going to choose Y will be the negative according to the battery, and positive now goes to X, right? So as we deduce, X is positive, and positive better to have the metal copper, right? So X with the copper metal, B or D now, and Y is the negative electrode, and negative electrode must be my object. So that's why Y must be my object. And finally, the electrolyte, which is Z, must contain my metal ion, right? So that's why water, just water is not okay. So eventually having the aqueous state of the copper 2 sulfate containing the copper 2+ ion, perfect. So that's why the choice will be B.